Hey everybody, welcome to 2.4, Analyzing Systems of Inequalities. These notes are going to be based off of an example from the a previous 2.4 notes. It's this word problem right here. It says you can spend at most $60 on beads. A bag containing red beads costs $2 per bag. A bag containing blue beads costs $3 per bag. You need more bags of blue beads than bags of red beads. You need a minimum of 4 red bags. What are the potential quantities of red bead and blue bead bags that you can buy? So we came up with these inequalities in those notes. So just to kind of go over everything real quick, we used X for the red bead bags and Y for the blue bead bags. And so the first one was from this $2 per bag and $3 per bag. And it says you can spend at most $60. So at most means less than or equals to. So we had 2x plus 3y is less than or equal to 60. Then the next one comes from this. You need more bags of blue beads, that's y, than bags of red beads, that's x, so y is greater than x. And then the last one came from you need a minimum of 4 red bags. Minimum means greater than or equals to, so red bags was x, so we have x is greater than or equals to 4. So you can graph these on your graphing calculator. I use Desmos. So type these into Desmos, and then you got to scroll over a little bit. You got to find the common shaded region, and the common shaded region, that's where all three inequalities overlap with one another, makes this triangle right here. Okay, so to answer my first question, I wrote, well, the first question is, if I buy 4 red bags, what's the minimum number of blue bead bags that you can buy and why? So I wrote, the minimum number of blue bead bags we can buy is 5, and here's why. So looking at this graph, we have our three, I guess, vertices of our triangle. Here, here, and here. Okay, and so I'm asking for the minimum number of blue bead bags, so that's Y, and given that you've purchased 4 red bags. So we're looking along this line right here, the x is greater than or equal to 4 line right there. And you see I have 4 comma 4 highlighted. The reason why I have that highlighted is that would be the lowest number in my shaded area, the common shaded area. But it lands on a dashed line. So if it lands on a dashed line, you either got to go a little up or a little down. If I went down, that would be outside of the common shaded area. It would only be in these two here. So if I go up and I'm somewhere on this line, then that is in the common shaded area. So the next highest value up would be number 5, because you have to use whole numbers because we're talking about like buying bags. I can buy 4 bags, 5 bags, 6 bags, 7 bags. I just can't buy any decimal numbers of bags. So I officially wrote down the minimum number we can buy is 5. The lowest y value, on the common shaded area is at 4, but that doesn't work because it falls on a dashed line. So that's why I went 1 up. And the reason why it falls on that dashed line is because that inequality y equals x. 4 is not greater than 4, but you know what is greater than 4? 5. So 5 is greater than 4. So yeah. I'm going to move on to the next question. If I buy 4 red bags, what's the maximum number of blue bead bags that you can buy? And so you can see here I said 17. So what we're going to do is we're going to look at the graph, and we're going to go all the way up that line. And so at the top of the line is 4 comma 17.3, and it looks like it's going to say 0.3 forever. However, you can't buy 0.3 of a bag, so you could do 17. 17 would be the maximum number of blue beaded bags that you could buy. So that's what I officially wrote down right there. The next question says, can I buy 9 red bags and 5 blue bags? And I wrote no, because if all you have to do is just graph 9, 5 on here. 9, 5 falls outside the shaded area, the common shaded area between all three inequalities. But if I flip it to 5, 9, that's what I say right here. What about 5 red and 9 blue bags? The answer would be yes. So my explanation is 9, 5 falls outside the shaded area because of the inequality y is greater than x. Because, think about it, you can always prove these by plugging them in to each inequality, and they should make true or false statements, right? So if I plug in 9, 5 into the inequality y is greater than x, well, my y would be 5 and my x would be 9. 5's not greater than 9, so that doesn't make sense. So that's how I know that one's no. And then if I plug in 5, 9 into, this inequality, 9 is greater than 5. That checks out on that one. And then you'd have to plug it into the other two to see if it checks out as well, which I won't do on these notes, but you can clearly see that it falls in that common shaded area there. My next question says, what are some other quantities or ordered pairs that would work? There's nothing really to that one other than I just plugged in some points, and because I have the benefit of the graph and Desmos can plot individual points, you can just plug in to see what works. There's, many different answers, this point, this point, this point, this point, right? So I just highlighted 4 random ones. Again, just to kind of go back to the question prior to this, I could test these points by plugging them in algebraically into each inequality and see if they fit into those as well. But since we're using the graph on these notes, let's just look at the picture. It's as simple as that. So my next question is, what is the maximum number of red bead bags you can buy and why? So red bead bags was your x variable, not your y variable. The reason why I bring that up is when you look at your graph, rather than looking at the highest point of your common shaded area, you're going to look at the point farthest to the right of your common shaded area. Why go to the right rather than up or down? It's because red bead bags were the x variable, and so think about it. On a number line, the farther left you go, the smaller the numbers get because you're approaching negative infinity. When you go rightward on a number line, you're approaching positive infinity, so the numbers will get bigger. So the point farthest right on my common shaded area, my bounded region, is at 12, 12. 12, 12 falls on a dashed line. Anytime you land on a dashed line, you can't equal that. So what's the next highest value? That will be 11. 11, 12 works. Okay, if you went too high and you went to 13, you'd be outside the common shaded area, right where my laser pointer is. So that's why it couldn't be 12. If this line were solid, it could totally be 12. But that line's not solid, it's dashed. You can't land on a dashed line, so that's why I went to 11. And so this kind of just sums it up right there. Since we're looking for the max x value, we need to look at the farthest point to the right that doesn't land on a dashed line. 12 lands on a dashed line, 11 doesn't. My final question ended up being really similar to the second question on here. I wrote, what's the maximum number of blue bead bags you can buy and why? That is going to be 17 again, because you would go, so since blue bead is your y value, you would look at the highest y value of your common shaded area, which is 17.3 forever, but you can't buy 0.3 of a bag, so 17 is the largest whole number value inside of your common shaded area. So that's going to draw these notes to a close. I thank you for watching. I hope you learned something, and goodbye.